the Siza water reuse plant. The sewer entering the Fraser's wastewater treatment works is predominantly domestic in nature. The preliminary and primary wastewater treatment process comprises screening and degritting. The screens may be raked or cleaned mechanically, or they may be hand-raked. The grit is removed and taken to the landfill site. The flow is then measured by a Venturi-type measuring flume prior to being distributed evenly to the activated sludge aeration basins. The activated sludge process involves the production of microorganisms capable of stabilizing the organic content of wastewater. The microorganisms are thoroughly mixed with organics under conditions that stimulate their growth, and waste materials are eliminated. The concentration of sludge is built up by collecting the sludge and reusing it in the treatment process. This reused sludge is known as return activated sludge, RAS. The mixture of wastewater and activated sludge is called mixed liquor. The mixed liquor flows to a secondary settling tank or clarifier where the sludge settles out. The return sludge concentration can be controlled by the using of telescopic valve, which will assist in reducing the suspended solids or minimize the carryover of solids. The turbidity of the settled effluent is 2 to 5 NTU. The effluent flows to the chlorine contact tanks for disinfection. The contact time is approximately 45 minutes at peak flows, and baffles have been installed to increase the retention time. The free chlorine residual of 0.25 mg per litre is maintained to adhere to the general standards for all effluent being discharged to the maturation pond and subsequently the stream. A percentage of the chlorinated effluent is transferred and stored in a storage tank, Mini Apollo, as the raw water of the reuse plant. The media filtration step is the last solids barrier in the process. The pressure filters are fully automated and consist of activated filter media, AFM. The high-quality glass filter media can remove particles as small as 1 micron. The AFM is a direct replacement for sand and can resist bifouling, bicoagulation, and momentary wormhole channeling of the unfiltered water. The filtered water passes through the ultrafiltration UF membrane with a pore size of 0.001 microns. The UF eliminates suspended solids and pathogens such as viruses and parasites and produces sparkling clean water with extremely low turbidity values. The reverse osmosis membranes remove particles, dissolved salts, organics, silica, chemical contaminants, metals, bacteria, viruses, endotoxins, and various other impurities. The removal of these dissolved solids ensures that the water is not brackish, ensuring a better taste of water. The new spec of RO installed increased the flows through the membranes whilst reducing the membrane pressure, thus saving us costs on CIP chemicals and reducing plant downtime. The RO brine is blended with the final effluent and discharged to the maturation pond, where it is closely monitored to ensure general standard compliance. Ultraviolet radiation, together with pre- and post-chlorination methods, proves to be an effective disinfection tool in the recycling plant. The UV is fully automated and is easy to maintain in-house. The running hours of the lamps are monitored for replacement and minimal downtime is required for replacement. After filtration, chlorine is dosed in line before the storage reservoirs. A free chlorine residual of approximately 1.5 mg per litre is maintained, which ensures no biological regrowth in the reticulation system or in the reservoirs will occur. Sampling and analysis occur at various points throughout the wastewater and reuse processes. Process controllers monitor both the wastewater and reuse plants on 12-hour shifts. Testing is conducted hourly by the process controllers and composite samples are taken to the internal lab for verification. An external laboratory conducts compliance monitoring on a weekly basis at the storage reservoir and distribution network. A facility to augment the reclaimed water supply by the addition of portable water is available. The purpose of this is to ensure the continuity of supply if the water demand exceeds the recycled water volume, leaving Fraser's wastewater treatment works. It is also available for blending purposes. The final product is distributed to the network and the reservoirs.